Greetings, my little triglets. Welcome to section 4.3. Well, we've done a lot with sine and cosine graphs, so now it's time to give equal time to the other 4 trig functions. Now, tangent, we're going to start with that, is the same as sine over cosine. Now, when you have a fraction, the bottom cannot equal 0. So when that happens, we have an undefined section, and so tangent is going to have some undefined parts to it. All right, so if I were to make an XY chart and put all the points in from the circle, I would get a bunch of points out. So I'm going to put those points on here. 0, 0 is one of them. And then let's put pi over 2 here and pi. Here's pi over 4, pi over 6, pi over 3. So here's 1, here's 2. So approximately pi over 6, if you put that in for tangent, you're going to get a point about right here. Then pi over 4 is up at 1. Pi over 3 is up here. Pi over 2, now that's where cosine is equal to 0. So pi over 2 is going to have a hole in the graph. So what we do to designate that undefined part is we put a dotted line down there. That dotted line is called an asymptote. A-S-Y M-P-T-O-T-E. It's kind of like a boundary. Okay, the graph gets very close to it. Now, if I put in a fraction very close to a half, but not quite a half, it will get closer and closer to this line, this dotted line, but it never quite reaches it. Now, if I go in the other direction, to negative pi over 2, I get all the negative values, these same ones. So it's going to look like that. So here we have the tangent graph. It looks like that. Looks very similar. Well, you're supposed to go through the origin. I kind of missed it. Similar to the x cubed graph that you might have learned in Algebra 2. Okay, so that's tangent. If you notice, the period, the wavelength is from here to here. That's a distance of pi. For sine and cosine, it was always 2 pi. Well, instead of using 2 pi over b, that's for sine and cosine. For tangent, we use pi over b. We use that for tangent and its evil twin, cotangent. And the evil twins here use 2 pi over b. So it's a little bit different because the wavelength is different. Now when you graph these, I'm actually going to have you do 2 waves instead of just 1. So be prepared for that. So if you notice, tangent is split between the right half and the left half of the x or the y-axis. So this, even though the period is pi, this label is pi over 2. This label is 1/2, negative 1/2 pi, negative pi over 2. So when you go to put your boundaries in here, whatever the period is, you just cut it in half, and half goes to the right, half goes to the left. Now let's look at that. Look at compared to cotangent. Y equals cotangent is a little bit different because cotangent is cosine over sine. So now the dotted lines are going to be where sine is equal to 0. And that happens at pi and 2 pi. So I'm going to put a few waves in here. And then it also happens at 0. Now cotangent, instead of rising left to right, is actually falling. So cotangent's going to look kind of the same, but a little bit different. I'm going to put in the dotted lines here. Isn't that cool? And here's one here too. And then you can draw as many tangent waves or cotangent waves as you want. We're just going to do 2. But you got to make sure you label the dotted lines. That's going to be our big deal with these evil twins. Now let's do some changes here. So tangent, let's try tangent of 1/3 x. Now this is A, here's B. We don't have a C or a D, so this is B. And remember, it's pi over B for tangent and cotangent. So pi over 1/3, which would be 3 pi. So that's one wavelength is 3 pi. Now remember, tangent was the one that had the dotted lines. Whoops, let's go back. One more. The dotted lines, half and half, half to the right, half to the left. If 3 pi is our entire wavelength, if this is 3 pi, oops, I probably should change that, 3 pi, then I make sure I have to go half this way and half that way. So these labels would be 3 pi over 2 and negative 3 pi over 2. And then tangent is a rising graph, so it looks like that. Now let me put in one more asymptote. It'd be over here. So I have to extend it. Now what would be the point here? You don't just add 3 halves, you have to add 3 pi. This distance from here to here is also 3 pi. So 3 halves plus 3, that's 4.5, which is 9 halves pi. So this is going to be at 9 pi over 2. Okay, you just have to add the wavelength to get to the next asymptote. Here I would subtract the wavelength. The period is 3 pi, the wavelength is 3 pi, so you just add it to get to the next asymptote. And remember, try to keep everything symmetric. That length has to be the same as that. So don't put it too close. All right, so the changes are going to be very similar. Okay, let's talk about cosecant. Well, let's do secant first. Remember, secant is 1 over cosine. So what we're going to do is we're going to draw cosine and then flip over parts of it. Okay, so we're going to use cosine as our guide. Cosine as our guide. So our normal pi, 2 pi, 1, negative 1, draw in cosine. Now, cosine cannot be 0, cannot equal 0. That happens wherever it crosses the x-axis. So that's where our dotted lines are going to go. Asymptotes go here and here. Those asymptotes act like a knife and they cut the graph. And what happens is the pieces, so this curve here is going to flip over and become this. And you just add arrows to show that it can go forever. This piece gets flipped up that way and this piece gets flipped up that way. So the red is the secant graph. Okay. So you use the cosine graph, you draw everything according to that, all the changes and everything, and then the last step you do is you put the asymptotes in and then you flip the graph over. Let's try cosecant. Let's try the next one. Cosecant. Let me get back. Cosecant is 1 over sine. So we're going to start off with the sine wave. You guys should be used to this by now. And we draw a wave like so. And then wherever it crosses the x-axis, these 3 spots is where the dotted lines go. I don't need to do it for the first. Well, I could draw it in there, I guess. And then you just flip it over. So this one's a little bit easier because the curves are all intact. They're not cut in pieces. So that's the cosecant graph. So you do all changes A, B, and C. Then you put in the asymptotes. Then finish D. The reason I want you to finish D after the asymptotes is because sliding the graph up and down, you need those boundaries to keep it lined up. You want to keep it lined up, you know, whichever way you're moving it, you want to keep it between the dotted lines. So the labeling is much easier. Okay, I'm going to do one problem that has a change for, let's do secant. Let's do y equals -4 secant 1/4 t. All right, let's start out with our normal graph. Now, actually, I don't want to do that. Go back. I want to write things down over here. The amplitude is 4. We're going to have to flip it. The period is 2 pi over 1/4, which would be 8 pi. So 8 pi is going to be my first mark out here. Cut it in half. Label this as 4 and -4. And secant is the brother to cosine. So I'm going to draw cosine in. Okay, and then I've got to flip it for the next part. So I'll do that in green. So I'm going to look like this. And then I put the asymptotes in, which are right here and right here. And then I flip the green over. So it becomes this, it becomes this, and it becomes this. Okay, asymptotes need to be labeled. This is 2 pi because it's half of 4, and this would be 6 because it's halfway between 4 and 6. Okay, make sure you're labeling everything. Okay, I think that is it for now. Tangent and cotangent are a little different. One goes through the origin and is half and half, the other one is not. Secant and cosecant, you're actually using the cosine and sine until the last step, and then you're going to flip them over. Okay, so hey, that's it for now. Let's remember the motto. It's all good.